Okay, so we're going to work out this integral here, cosine of 4z divided by 4z minus 1 with respect to z on a contour C. Now this is our contour C which we've been given. So let's just draw this up now. So the contour C is 2. So that will be 2. That's our contour there, imaginary and real. So it includes the boundary, which is 2. So this is a simple closed contour, which is good. And this simple closed contour is defined inside the region of the complex plane. So it's in all the complex plane. So basically this is all set now for Cauchys integral formula. So Cauchys integral formula. Okay, so Cauchys integral formula states this, that the integral of f of z dz equals 2 pi I times the limit as z approaches alpha. Alpha is going to be the singularity of this function here, which we're going to go through in a minute. And we multiply this, sorry, the limit of f of z times z minus alpha. So where the function, this function, and z minus alpha, basically the idea is to get rid of this denominator. Okay, let's find the singularity of this. So 4z minus 1 equals 0, 4z equals 1, z equals 1 over 4. So therefore we can let alpha equal a quarter, and f of z is just going to be this function here. Okay, so let's go with this Cauchys integral formula now. We've got all the bits in place. We've got the function, we've got the singularity, 2 pi I times the limit of this function. So now we've got 2 pi I times cosine, well, limit, let's just put this in first, z approaches a quarter of f of z times z minus a quarter. Okay, this is our function f of z. Right, so as this function approaches a quarter, we're just left with cosine 4 over z. So it equals 2 pi I times cosine 4 times a quarter, so which we can now simplify as to be cosine 1. So it equals 2 pi I times cosine of 1. And that is our answer. That is Cauchys integral formula.